Gabriel Cramer published this rule over 260 years ago in 1750. It is fundamental to many aspects of engineering. Cramer's rule is a formula used to solve systems of linear equations through determinants. However, it can only be applied to a system containing the same amount of variables as equations, so they must be square matrices.
Cramer's rule is done in 5 steps. Step 1 is to put the variables and the coefficients of every equation you have on the left hand side and the constants on the right hand side. This is done as seen above. Step 2 is to convert these equations into matrix form or augmented matrix. To do this, you get the variables into columns and then remove their variable sign. So there'll be x, y, z, and then a line and then constants as seen above. Step 3 is to calculate the determinant of the plane matrix. This is the thing ignoring the constants. So this is done by the 3 times 3 determinant formula, and we'll go through that in the example. Step 4 is to calculate the determinant for each variable. This is done by replacing the column where the equivalent variable would be with the constant. So for the determinant x, you replace the x column with the constants, and with the determinant y, you replace the y column with the constants. You leave the other columns the same. And finally, step 5. This is where we find out the answer. So basically what we do is we just put the derivative of the variable over the plane derivative for every variable. For x, for example, it'll be dx over d, and then you just do it for the other one. So now you have the answer to the equations.
So we start with these 2 equations, which work out to give 2 separate values for v1 and v2. To solve for these 2 values, we have to put them into the form of a matrix, into this form here, where a, b, c, d is the coefficient matrix and k1 and k2 is the constant matrix. As can be seen here, it is written out as the coefficients of v1 and v2 in the first 2 equations as the coefficient matrix. v1 and v2 are the second matrix, which is the values we're trying to solve for, and the right hand side matrix is the constants. Moving down, these 2 formulas here are how we derive v1 and v2. This is done by placing the coefficient matrix as the left hand side of the coefficient matrix and then dividing by the determinant of the coefficient matrix to find v1. And then for v2 we do the same, but instead of putting it on the left hand side, we put the constant matrix on the right hand side of the coefficient matrix and then divided by the determinant. As can be seen here, the determinant is worked out to be negative 1.793. Moving down, we can see that v1 is found by dividing that entire matrix, which is swapped in with the constant matrix, and then dividing by the determinant. This gives a voltage of 6.68 volts. For v2, we see the same thing, but with the right hand side swapped out for the constant matrix, which gives a value of 9.71 volts. These 2 values of the voltages are the voltages going at the 2 nodes that these 2 equations up here represent. These 2 equations are the nodal voltage equations for which we solve down here.